Hi there, welcome to another video here at Prof. Paul B. And today we're going to be looking at creating a few things actually. We're going to be creating class diagrams using Visual Paradigm within NetBeans. We're also going to be looking at a couple of very important design considerations when we're creating applications, systems really. We're going to be looking at cohesion as well as coupling. And again, when we want to create applications that are more maintainable, flexible, reusable, extensible, these are the magic words we keep using over and over, and that's really what we want. What we want is one of the design considerations that plays a big role is what we call loose coupling, and we're going to be talking more about it later. Basically, loose coupling means that the classes or systems, but in this particular case, we're talking at the application level, not at the system level. But in an application, you want your classes to be loosely coupled. So what does that mean? That means that you don't want your classes to be too dependent on knowledge of each other, if that makes sense. And we're gonna explore that a little bit more. And another way probably a more pragmatic way of looking at it is you want your classes as loosely coupled as possible, so that and by doing that, when you do changes in one class, don't always necessarily precipitate the requirement of changing the other class. Okay, so that's kind of maybe the way we're going to look at it. And yeah, we're going to continue from there. And we're also going to look at cohesion. Cohesion basically is we want one class to do one thing and to do that one thing well. If a class has too many responsibilities, is taking on too many different roles, then that's typically not a good thing. So we're going to be looking at that as well. And we're also going to be looking at Enums. We're going to be looking at Enums to enhance looser coupling. So if you're ready, let's get started. I do have some code in the that I put on my GitHub account, and I will put that in the comments below, or in the description, I should say. And I'm just going to grab the link right here, and there we go. So I'm going to clone that project, and I'm just going to work from it locally after that. I'm not going to be pushing it or anything. You can look at a previous video for a lot more on GitHub, but right now I'm just going to open up some starter code. Let's go ahead and do that. I'm going to go here in my NetBeans to team, git, and clone, and I'm just going to paste that the Winter 21 card game. That's exactly what I want. Although I will put it somewhere else. I'm going to I created a new folder for all my videos. And let me go ahead and clone it from there. And I'm going to select the main branch. I renamed the branch to be better suited for this day and age. Let's go ahead and click on next. And there we go there. In the checkout branch. And yes, we will finish this. And of course, I want to open it. Otherwise, there's not much left in the video. So let's go ahead and open it. Open this project. We'll just take a quick look at it. There is one class, and again, it's a starter. It's something to get started with. Let me close that repo. We might open it later. But if we take a look at the code, all it is there's a main method, and I commented out some code because we're going to be adding a class, and I just wanted it to compile for now. That's it. But how we're going to add a class is we're actually going to use Visual Paradigm. We're going to what's referred to as forward engineer. We're going to use the Visual Paradigm modeling tool to actually create a class. First, we're going to create a class diagram, create a class within the diagram, and then we're going to actually create the code using that. So it's kind of cool. So first thing we want to do, and you do need Visual Paradigm installed on your computer to do this, and you do need to have it integrated with NetBeans as well. So I'm just going to right click on the card game, and notice you'll have Open Visual Paradigm Professional here. If you don't have that, you could look here. You might have the Start Visual Paradigm Professional. Okay, so if you don't see it in the drop-down menu here, you might have to get it from there. So let's go ahead, and I'm just going to open it. And this is, I'm actually going to create it within the project itself. That's just my selection. I'm not going to be pushing this to the repo, but I just want to just have it in one place. So I'm just going to save it in the same folder as the project. And I'm going to click OK. So let's get started. And I've activated Visual Paradigm. Notice now the open is grayed out. And what I'm going to do is I'm actually going to, there's a few different ways of doing this, but I'll just be consistent and show you the one way. I'm going to go to my Diagram Navigator and go to UML Diagrams, Class Diagram. I'm going to right click, New Class Diagram. And this happened very fast on my computer. This might not happen quite as fast on yours. And I know I've had some students saying, "Oh, I brought the output up. I brought the wrong window up." So what I'd like to do is I want to bring the class diagram up. There we go. And now we're back to where we want to be. Okay, we'll keep that output down here. Now what I want to show you is, notice we have the default. By default, it gives the default package, and we definitely do not want that. That's one thing I'm not too crazy about the Visual Paradigm, especially when you're opening it in the context of an existing project in NetBeans. It'd be nice if it kind of at least had a drop down of the packages that are available in the project, or that are created, I should say. But it doesn't have that. So we're gonna figure something out. We're gonna actually take a look. Let's just go to Window. I can access it. I can see it right here in my projects, but I just want to make sure everybody knows how to access it if it's not clearly visible. And you'll notice that the card game application has one package, and that's card game. And that's what we want to put here instead of this default package as well. Because if we don't change it, what's going to happen is when we create a class and then we basically forward engineer, it is going to put it in a default package, which is not a good thing. So what I want you to do is, I'm actually going to put the package name to be the same as here. And I'm just going to double click, and capitalization does matter. Okay, Java, remember everything in Java, capitalization matters. Okay, so I just created my new, I have this class diagram without anything in it yet, and I changed the package from default package to card game. So now what I'm going to do, and this matches the package name, and the capitalization matters. So here's my new class. I just dragged it over here from my toolbox and onto my canvas. And let me just go ahead and try to make it bigger. It's a little bit, there we go. So I'm going to make it a little bit bigger, and I'm going to call this class card. And so right now this class does not exist. It's a diagram, and it's a class, it's a class diagram, and it's a diagram of a class in my class diagram. And now what I'm actually going to do is I'm going to add a couple of attributes. Visual Paradigm calls data fields, attributes, properties. There's a lot of different terminology, but what we're going to do is we're going to create a couple of attributes. We're going to create one for value and one for suit. Right here, what we're modeling is the typical cards of the ace of spades and that kind of thing. So let's go ahead and do add attribute with getter and setter, and we're going to call this one value. And we want to specify the type, and the type is going to be an int. Don't worry, we're going to fix it out. We're going to make this much better in the future, later in this video. And I just hit enter there, and now it's going to have another attribute. So I'm going to do suit, and notice it's putting them as private, and it's creating the getters and setters for us. So now I'm going to put a colon, and for suit, we're going to put it as a string for now. Okay? And I'm going to hit enter. And those are the only two that I want. Visual Paradigm is ready to create another one for us. But all we have to do is hit escape. And that did a couple things for us. I'm not sure why it brought it down there, but we see that it did remove that new attribute that we didn't want to add. And so here's my card class diagram. And now what I'm going to do is I'm actually going to go to my Diagram Navigator. I see it here. If you don't see it there, again, what you can do is you can go to View, Visual Paradigm, Diagram Navigator. So you can always access these windows from here. And every once in a while, NetBeans windows get confused, and you might not be able to see, let's say the output window won't show up. One trick that you can do, it's not really a trick, but one thing that you can do is if all else fails, you can't find the window if you do reset windows. I'm not going to do it now. This kind of puts your IDE back at the factory position, factory settings, if you will, with the windows. And then you can actually access the windows, through the different views as well. So now what I'm going to do is I'm going to go to the Diagram Navigator, and I can see here, it's right here. And I'm going to do I'm going to come here to this little tool ribbon up here, and I'm going to click here, and note I'm going to do the update code. Okay, so it's the third one from the right, and I'm going to do update. Oh, you know what I'm going to show you before doing this is I'm actually going to show you how to set something up so it looks better in NetBeans. So I'm going to go to modeling, and unfortunately it's not on the screen, but I'm going to application options. And I know some people, this is the exact same thing that unfortunately it's not the best. And some people who have the laptops, and depending on your screen resolution, you might not be able to see this option, and it's called application options. Let me see and I just clicked on application options, and what I'd like to show you, this is completely 100% optional. So I am showing you, if you click on the NetBeans here on the left, and you go to code, and you go to, let me just see, here we go, sorry, brace and indentation. You might want to change the indentation policy. By default, it's tabs. You might want to change it to spaces and 4, because this is the default out of the box NetBeans configuration, and it makes for a more consistent code. Okay, so I already did it, so I don't have to do it again. And again, I know on some machines, you don't actually see any. This is a perfect example. Is sometimes you only see that. And let me just show you what it looks like. And I think there is a workaround. So this is what I see, and this is the one right here that you want to get, is the application options. I think the issue is on Windows machines, and there is a workaround, but I'll leave that up to you to discover. Again, it's optional, and your code will still be generated, and I'll show you how to make the code better, prettier, if you will, if you can't set that option. So now, after setting that option, the optional one, I'm going to go to the update code, and notice doesn't seem like too much happened. But if I go on my projects, and again, if you're having a hard time seeing it, you can just click on the window projects right there. So I'm going to click on my projects, and notice, yeah, we're using Git and screen. Notice we have a card class, and there's our card class. So actually, Visual Paradigm created this class for us, which is kind of cool. This is called forward engineering. We created a diagram, so the designer created a diagram, and now the designer can actually create code. Okay, it's a shell, but it does create the setters and getters, and it does its job. Yeah, so now what we're going to do is we're actually going to create a 2-argument constructor. Okay, so I'm going to go ahead, hit enter a couple times. I like to put my constructors right below my data fields or attributes, and I'm well, let's use the IDE to create this constructor. I'm going to right click, insert code, and I'm going to insert a constructor. I'm going to select all, and I'm going to generate. Okay, it's nothing too special about that. A 2-argument constructor. And notice, because I set if you could not set those settings, you could, I'm going to hit save. You can go to source and format, and the IDE should format the code according to its its default preferred way. Notice you can actually change the brace style and whatnot. I prefer the end of line brace style, but again, that's a matter of choice. So we created that, and now if we go back to our diagram, and here's our diagram, notice the diagram does not have that constructor. So what we have to do is we actually have to update the UML model element. So I'm going to go to my diagram navigator here. And again, you can just get it from here, Diagram Navigator. And I'm going to notice this button has a drop down, and there's 2. We did the update code that will take your diagram and update the code and create the code. And we also have the reverse, which is update the UML model element. And that's what we're going to do. And notice it did add the constructor right here at the end. One thing, it'd be nice if it kind of respected the order of the methods. If we look here, the constructor is first. And I typically like to have the constructor first in the class diagram. But what you can do is you can actually select it and just drag it up. Okay, so it's not a huge deal. And I'm going to hit save. So here we have our class diagram. We have our, we created our, well, here, let me just do this. Let me just do this. And let me just come here. So we did this, we did this, we did this. And what's here? This is what we did. So we added a UML class diagram to an existing NetBeans project, and we created a class. We did the update code, and then we added a 2-argument constructor, and then we did the update UML model element. And then finally, we just did a little house cleaning as we put the constructor first, just because that's the way it looks better. And this is commonly referred to as round-trip engineering. Okay, it's kind of cool. And I've used these tools extensively. Actually, I used rational rows way back when it was like $20,000. But I use that in developing applications, industry applications. So it's kind of cool. And so yeah, let's see what we're going to do now. Now that we have our card class, now we're going to go ahead and we're going to, let's try it out. We're going to uncomment this code. Again, this is code that I don't feel like typing right now, and that I supplied to my students as well. So we're just going to uncomment. And if you want to know how to uncomment, my students ask me this. On a Windows machine, it's command slash, and on a Windows, it's control slash. Okay, so let's go ahead and do that. And we're going to notice all the Git, because of the Git, it's highlighting stuff. We're not going to worry about that too much for now. We will be committing, actually. Okay, so, I didn't even do a single commit yet. Oh, well, that's not a biggie. Okay, so, oops. Let's do this one more time. You'll notice how I have this line selected and it's not commented. That's why it's commenting again. Okay, so let's go ahead and just make sure we select the commented lines. And there we go. So let me go ahead and save, and I will do a commit just to get this distraction of the different colors. And are we still not compiling? Okay, maybe there's something I did not do right. Let's take a look. Let's do a save. Everything looks okay. Oh, we did forget to do something. Okay, so here what I forgot to do is I forgot to create an array for the suits. Okay, so that's one step I forgot to do. So it's nice the IDE is telling me, hey, this still does not compile. So let's go ahead and do that. I'm going to create public. It's going to make this a static constant array, and final. And we're going to call a string array called suits, S-U-I-T-S. And let's go ahead and then populate this with, just put this over here. Let's do this hearts. Oops, hearts. Oh, come on, Paul. Hearts. And the diamonds. Diamonds. And spades. And clubs. Okay, and of course we need our semicolon here at the end. So there's something still wrong here. What's wrong? Let me just save this. Let's see what is wrong here. We have suits is equal to heart. That's a string, 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 string. Let's see what is wrong. This looks right. Does anything look wrong to you? It looks right to me. And this is sometimes my students will actually be able to fix my code. You know what I'm going to do now? When things look right and you're just scratching your head, it's always good to do clean and build. And I find that this helps, especially in the when visual paradigm is in the picture as well. So let's go ahead and do that. Clean and build. Okay, that still didn't. Oh, okay, well, we're still not compiling here, which is okay. I'm sure some of you are kind of yelling at me right now. You forgot to declare it as an array. Okay, so that's my bad. It happens to the best of us. And oh, yo and behold, everything compiles. Okay, let's go. So life is good again. So now let's just go ahead and take a look at, well, you know what? Now that it's compiling, I think it's a good time to commit. Okay, so we added the card, we modified the card game. So I'm going to go ahead and I'm going to commit this. Whoops, git and commit. And what I'm going to do is I'm going to call this my baseline application. My baseline. There we go. Okay, baseline. Before refactoring. Refactoring. Okay, I'm going to go ahead and commit. And we'll wait to make sure everything is okay. So yeah, now it's showing them ahead of one. I'm not going to push this in this lesson because I want you guys to have the repo the way we started with it as well. Let's go ahead and let's get rid of this. I'm going to go to clear. That's out of the window. And let's go ahead and run this just to see what it's doing. And it is, so it's saying, okay, basically it's creating 7 cards. And let me just see. It's creating 7 cards, and then right now we're displaying them. Typically, the application is supposed to be modeling like guess a card, basically. But here we're just, for debugging purposes, we're displaying it here. And now what I'm going to do is I'm actually going to pick a suit. Let's pick one that's in there. I'm going to pick the 3 of spades. There we go. Oh, spades is 3. Yep. And we're going to pick 3. And we see right guess. And let's try it again. And we're going to pick something that's not in there. And what's not in there? There's only the 2 of spades. So I'm actually going 2 and 13. So I'm going to choose the 10 of spades. And the 10. Oh, okay, so no match. Oh, well, let's take a quick look at the code. So that's what it does. Here's what we're doing. We'll take a quick look at it. We're creating a hand, right? Here's an array using the proper notation. And we're creating an instance of random. I kind of like, you can use math.random. I kind of like using random because then you don't have to do the multiplication. And here we're just looping through our, we're looping for the number of elements in the hand.length in the hand array, creating a random number, and this will actually generate a random number between 0 and 12. Okay, it's not inclusive of the number here, so it's going to generate an int between 0 and 12. We want between 1 and 13, so we just have to add 1 to that. And here what we're doing is we're actually adding to we're getting the suit, and here we're actually getting from that suit array, because remember this array that we had a hard time setting up. So we're actually grabbing, no, this is element 0, 1, 2, and 3. Remember, arrays are 0-based. And again, because it's 0 to 3, we can use random.nextInt 4. Remember, the 4 will not be included. The endpoint is not included. And then what we do is we create an instance of card, and then we assign it to that element in the array. And here's where we're actually printing it out. And here I say for debugging purposes. So if you wanted to play this game, you could just comment this out. Okay. And now we're asking the user. So we're saying pick a card. We're looping through the array, and we are asking, we're displaying the suit. Here I'm doing I plus 1 because typically users are, here it is. Here, typically users are 1-based. Only programmers tend to be 0-based. So we want to make it look a little bit better for the user. So we're starting it at 1. And let me just go down here. That's why we're doing the I plus 1, because when I is 0, it's right here. When I is 0, we're displaying 1, and the array itself, 0 is hearts. Okay. So, and then we're getting the suit. And then we're say enter value 1 to 13. Then we're getting that value, and then we're creating the card, user guess card. So here we have to subtract 1 because remember we added 1 to display to the user. And here we're looking that we're assuming we're setting our match to be false. We're looping through the hand using a for each loop. And we're checking if the value is equal to value. And of course, suit is a string. So we can't use the double equal sign. We have to use the dot equals method. And if we find a match, we don't have to continue looking. We put the match to be true. And break is actually going to break us out of the loop. Like I say, we don't have to continue looking in the array if we already found a match. And here we're just using the ternary operator, which is basically, it's going to check this. This is a Boolean value. If it's true, the ternary operator will return right guess. And if this value is false, the ternary operator will return the third parameter, operand. That's the proper word. It's going to return the third operand, or it's going to return what's after the colon, basically. It's going to return the no match. And then we're just displaying that. Okay, so that's the code. Not too complex Java code, and we got it working. So let's see where we're at now. So we did that, and so here is where, let me just open this up here, just so we can. So we did that. We looked at this, and look. Let's just go back here. Notice this is notice we did it correctly here. So then we go back, we looked at that, and there's something wrong here for those of you who are interested, and I'm not going to cover it in this video. Notice we are, in this particular example, we have 2 6 of hearts, right? So that's not quite right. And but for the purposes of this video, we're not worried about that. And I'll leave it to you as an interesting exercise to figure out how to create unique cards. It's not trivial, but the answer is. But you have to kind of think outside of the box. Okay, so now there's the two. Okay, so what we did is we got it to work, right? It works. Okay, well, now let's take a look about the two concepts, the design considerations that we were talking about: cohesion and loose coupling. So for the cohesion side, all operations should logically fit together in the context of that one entity. Well, if we look at our card game application, or class, I should say, the main class, it's not very cohesive, because we are creating the cards, we're creating them, and then we're having a lot of interaction with the user as well. And that typically is not a good thing. And you may have heard about the MVC, the Model View Controller design pattern. And if you're in my course, you're going to hear about this later. And if you're at Sheridan, you're going to hear about this in Java 3 as well, quite a bit. But basically, it doesn't smell right, because this class is doing a bit too much. We're going to be fixing this at the very end. But actually there's a really bigger one, and it's the concept of loose coupling. So let's just take a look at this code. So if I decided, let's say, to add a new suit, let's say star, right? I'm inventing my own deck of cards. So I want to add a new suit called star. Now, what would I have to change? Well, I'd obviously have to change this array. And then I would have to come in here and notice here, all of a sudden, I would have to, well, there's more than 4 elements now. There's 5. I'd have to change this, and I would have to come down whenever we're coming here. Actually, it wouldn't be too bad here. Yeah, this part wouldn't be too bad. But imagine if we also wanted to add a new value, and the value. Well, okay. Well, here's the nub. Actually, it's not. Yeah, this is again. Let me go back to my slide here. There's more to loose coupling than just being able to make the modifications in one place. Right now, our class is our card game class knows the internal workings, if you will, of our card class. It knows it, and it knows it because, and we'll come back to this. This is important. This is used under fair use from the textbook that we're using. So here, what we see is that in our card game, we are saying 1 to 13, but look at this. The value is an int. So you could have a value of negative 345,000, right? The card class, the way it is now, would accept that. Now you could say, oh, okay, well, I can add I can throw an exception in the setters. True, but still the users of your class have no idea, right? Have no idea of the internal workings of your class. They have to know. Let me rephrase that. The users of this class, and who's the user? Is another programmer, right? Or yourself. The user of the card class is not the person guessing the card. The user of the card class is actually the card game class. So the card game class has to know a couple things, right? It's got to know that it's between 1 and 13, and it also has to know, hey, this is the array we have to use for suits. So it has to know that, right? Because if we look here at the public contract, and we'll get back to that in a sec, if we look at the public contract, all we have is, well, the suit has to be a string. So it could be any string. And the example I give is you could send in Avenger. That's a string, right? So let's go back to this slide, and this has a lot to do. Has a lot to do with coupling. And again, when you're designing your class, this is something that you should be taking into consideration, is that the class should be implemented like a black box. So that here's your class, and here's the signature, the class contract, which is called. And what's the contract? It's the signatures of the public methods and public constants. And clients, and here again, remember, clients is not the user guessing the card. The client is the code that is using the card class. And the clients use the class through the contract of the class. So if we look at our card class, we see that oh, I didn't update the UML. You could update the UML to get this string array as well. But this is the public contract. So we have no clue. We do have a hint about what should be strings, right? We have this string array, but we have no clue, right? The class has no clue of what the value should be. So we're actually going to fix that. And here's just another. We're just showing that again. So, and that's what this is talking about as well. Anybody, you know it's a string, but it could be any string, right? And there's nothing preventing you right now to creating a -5 of Avenger. which really does not make a lot of sense. So it's not loosely coupled, not at all. It's working, and remember that's what we're talking about. Is we want to make sure that the application works, right? Because if you have the most beautifully designed application but it doesn't do what the client wants, well, how much is it worth? Not a heck of a lot, right? So at least it's working, but now we want to make it better. We want to be able to, so right now it is working, and I am assuming that the user's entering valid data. Yes, we could, do some validation here, but we're going to make it a lot tighter, right? We're going to make it a lot tighter that we're not going to have to do that kind of validation. The compiler is actually going to help us. Okay? So that's what we're going to do. And we're going to be using enums. Enums are very powerful in Java. They are classes in their own right. They can have constructors, properties, methods. You can override the toString method. That's beyond the scope of what we're doing today. This would be like a 2-hour video. But we're actually going to use enums. So this is what we're going to do. We're going to modify the code. And let me just go over here and do something. There we go. And let's go ahead and come to our card class. So I committed. So this is the working version. But now I'm actually going to modify it so that I'm going to force the value to be a certain range, and I'm going to force the suit to be a certain range as well. And I'm going to do that by using enums. Let's go ahead and do that. And and some students sometimes ask, oh, can I create these enums because they are bona fide Java classes? Can I create them in their own file? And the answer is absolutely. You can create them in their own file. We're going to create them in the card class. It kind of makes sense there. But again, this is not, the specifications allow you to create these in your own class. And notice I'm typing the enums as all caps. And again, that's for the conventions that constants are capitalized in Java. And these are all constants. So let's go ahead and do clubs and spades and diamonds. Okay. And there's no comma afterwards. We're done. And notice you don't need a semicolon after this because this is actually an inner class. But let's go ahead and continue. And I'm going to remove my caps lock, public enum, and this would be value. And now we're going to do, okay, this is a little bit of typing. So ace, 2, 3, and 4, 5, 6, 7. My daughter is always, she always cringes when she sees me typing with like 4 fingers. She types, I don't know how many words a minute. Okay, 10. And then we're going to do jack. Oops. Jack, queen. And finally king. And now what we're going to do, so now we're going to save, and we are going to change so right now, this is an enum. So an enum really is like a collection. The easiest way to look at it is like a collection of constants, a named collection of constants that allows you to very strongly type your, let's say, variables or parameters so that they will be enforced at the compiler level. Okay, so that's the really the big benefit of using enums. And so we don't have to, we won't have to in our set suit here. So here we could actually check the array, if it's not in the array, throw an exception. But by using the enum, the compiler is going to be doing that for us. Okay. So the compiler will actually, the compiler is not going to be checking inside. It won't compile if, you'll see. Just trust me on this. So now what we're going to do is we're going to change this value to, nope, not all caps. We're going to change this value to val. Oh, there we go. So this means that this variable value, the data field attribute, can only take on one of these constants. Okay, so that's how the compiler is actually going to be checking for us. And the same thing for suit. We're going to actually change this. Instead of accepting any old string, now we're only going to accept a suit. I'm going to go ahead and save this, and now our card is not going to compile anymore. We have to refactor. So right now, I typically call this like when I was working in industry and my developers were working on something and we're talking about the project, I would always ask them, is the patient on the operating table, or can you run it? So right now our patient is on the operating table. We still have some work to do before we can sew them up and work on them. So I'm not going to be using this array anymore. And now this is not compiling. And see, here's perfect example. Okay, that's not working. That's fine. Oh, there we go. So right now our application is not compiling because we're trying to put, see, notice our value here is an int. So we're trying to put an int into the value. And the compiler is saying, you can't do that. I need a value, right? So let's go ahead and put the value here. And notice, I will mention something here, just as a little refresher, or maybe something a little bit new, is this syntax here, this dot suit equals suit, is required. This suit, notice the highlighting in NetBeans. This suit is referring to the suit that's coming in as a parameter, but this dot suit, notice, is referring to the property or the data field or the attribute. And the only way to get that is to add the this keyword. If you don't have the this keyword, then this is putting suit equal to suit. So it's putting the parameter value equal to itself. So and the IDE is kind of telling us here, it says what? Assignment to itself. So this is not the way to do it. So now we're doing this dot suit equals suit. And again, this is not compiling because now we're trying to put a string into something that can only accept a suit. So the way to fix that is we just do this suit. There we go. I'm going to hit save. I like hitting save every once in a while. Now we got to refactor our getters and setters. Again, the get value, we're trying to return a value, but here we're saying we're returning an int. So let's go ahead and change that to value. And I think you get the picture by now, right? So I'm going to do the value and the same thing here. We can't return a string because it is a suit. And the same thing here. There we go. This is going to be a long video. Okay, so now our card is compiling. Yay. But oh, what's going on here? Now our card game is no longer compiling. Well, there's a few things, right? There's a few things wrong. One is, well, here we don't have that array anymore, right? So we don't have that array anymore. So what do we have to do is we have to, you know what? I'm looking at my notes and yeah, let's go ahead and do that. Actually, let's go to the Diagram Navigator. Don't worry about the card game not compiling. Don't worry, we're going to fix that. I'm going to go to the card game, to the Diagram Navigator. Remember, if you can't see it very well, it's right there. And I'm actually going to click on Update UML Model Element again. Let's go ahead and do that. And I'm going to go to my diagram. And you'll notice that, well, one thing is they put the value in the suit as properties, but you'll see here they put it as value and suit. And it changed the constructor, right? So it did update it. But I also want to see the enums here. And how we do that is we go to, where's that model? Oh, here we go. View and the class repository. Okay, there's a few different views. And in the class repository, you'll see here, if I expand the card, you'll see the suit, which is one of the enums. And let me just move it up a bit. And we see the value, which is the other enum. Remember, enums are classes, special classes. And we're not going to talk about them too much, except just a little bit. And I just want to talk a little bit about this in the diagram. So the bottom arrow, this represents a containment relationship. Okay, so this, if we would have created this enum outside of the class, we would not have this relationship. And it's the same thing here. And this, let me just move this up a little bit. This arrow up here represents that we're using this enum. And where are we using it? We're using it in the suit property. And the same thing here, we're using the enum value. And where are we using it? In the data field or the attribute property called value. Okay, so I just wanted to show you that, how we see that in the diagram. And so now what we're going to do is we have to fix up the code. So let's go back to my card game that is no longer compiling. And what I'm going to do is, first thing we're going to do is we're actually going to do a, we're actually going to create our arrays. No, sorry, we're going to be using our enums instead of using the arrays. But this is something I'm going to be doing now, and then I'll show you. I'm going to be doing this slightly differently because I thought about this. I thought about this after my last lesson, or this morning. I forget, but I think there's a little bit better way of actually doing this. And we're going to deviate a little bit from here. And notice we're going to be using this card.value.values. Let's just think about that. What is that? Well, the .values method, and it's right up here, it returns the list of enum constants as an array. Okay, so we're still going to be using an array, but it's going to be the array of the enums. And so notice here, the card.value is the value enum, and the .values, that is going to be an array consisting of all of those constants. And we're also going to use the card.suit.values, and that's going to be the array of the suit values. Okay, what I think I'm going to do things slightly differently, and I think it's going to make it a little bit easier. What I'm going to do is I'm actually going to introduce, oh, look at this scanner. This is, I don't like, there we go. The OCD in me likes things to be nicely lined up, and you should too. If you're a developer, it makes your code a lot easier to maintain and read and update and whatnot and refactor. So let's go ahead, and it's so important, and I'm going to share it with you here on YouTube because not all of you have the benefit of being in my class. But I remember one semester I had a student that had a hard time with this code and wanted me to go over and take a look at it to help him out. And this was either Java 2 or Java 3, Java 2, I think. And I looked at the code, and the formatting was all over the place. Yes, it still happens. And I looked at the student and I said, you know what? I cannot read that. You have to format it, and then I'll come back and I'll help you out after that. And it's so easy to format in your IDE. You do source.format, and boom, it takes care of it for you. So I told the student that, and then I went to go help another student, and then I was walking back to come to see the student that the code was not formatted. He looked at me and said, "Oh, sir, after I formatted it, I figured it out." Okay, so it is very, very important. If you want to be productive, if you want to be a professional developer, one of the first things you have to do is make sure you format your code properly. Okay, so now let's go. And what I'm going to do is I'm actually going to, because we're going to be using these arrays often, I'm actually going to create, this is slightly different for those of you in my class. This is slightly different than what we did in class, but I'm going to do this. I feel like doing this. So I'm going to do, so this is an array of value, and I'm going to call them values. And I'm going to call them card values, just to avoid too much confusion. Card values is equal to, and here I'm going to do card.value.values. Okay. And the IDE is going to ask us to add the import. Let's go ahead and do that. Make sure you add the one for the card.value. Okay. And because we added the import, actually, let's go take a look at our imports. Because we actually added the value import itself, we actually don't even need this. Where is it? We don't even need that. Okay. So now we have So this is going to give us all the card values that can be obtained. And I'm also going to do the same thing with the, what's it called again? Those are the suits, right? Suit, obviously. So suit and card suits, again, just to avoid any confusion, is equal to suit dot values. Okay. So, and let's go ahead and import card.suit. So what this does is we created two arrays that can be together. So we created two arrays that are going to have all of the values. So the suit value is going to be an array that contains hearts, clubs, spades, and diamonds. And I think I said that wrong. But the card suits is going to contain hearts, clubs, spades, and diamonds. And the card values is going to contain all of these. Okay. So now let's go back. And now what we want to do is inside when we're creating our random cards, here we have to change some stuff, and we're going to do, and this, let me just see, we're going to do, we're not going to do, it can't be int value anymore. So we're going to do the value is going to be, and let's go ahead, we're going to be using this array, right? So it's going to be card values, and it's going to be, this is an array, right? So now is where we actually put the random number generator. Random, oh, come on, Paul. Random dot next int. And what we're actually going to put here is what's the upper bound? And we're going to make this as loosely coupled as possible. Well, the upper bound is the number of elements, right? And because arrays are zero based, and here we're going to go ahead and dot length, because arrays are zero based, this should give us, basically this is going to be, because the card values is, I'll talk about it for suits. Suits is 4. It's a bit easier. So suits is 4, right? So we're going to do the same thing here. So instead of value, instead of a string, we're going to be using a suit. Suit is equal to, and here we have to modify this, card value, card suits, and random.nextInt 4. And here I could leave this at 4. It would work, but I'm still using knowledge of how many are in here, right? So that would still be tightly coupled. And just hang in there, and you're going to see at the end the nice example that makes it so that it's a lot, it makes it very nice. So I'm going to do here, card, instead of using 4, instead of hard coding, and you should know by now, hard coding is typically not the best idea. Sometimes you do, but when you hard code, you use constants. And sorry, suits dot length. And control space. There we go. Okay. And now we have our card equals new card. So everything is lining up very well here. One thing we have to change here, and this is important, if you do not change this, one thing I want to tell you as well is I'm not sure if we're going to be using Visual Paradigm again. So I'm actually going to close it. And I tell my students this as well, because I know some students have machines. It seems to work okay on a Mac. It seems a lot of students on Windows machines, even if they're like gaming machines, it seems to be very slow. So I tell the students, if you're done using it, you can actually close it, and it'll ask you to save. And that's why I saved it in the same folder. So I'm gonna click on yes. Okay. Maybe we'll take a look at it later, and if we do, all we have to do is reload it. So it's not a big deal. You gotta save it though. So one thing we have to change is now we have to change this to be an S, because these they are no longer, this is no longer an int, and the string will accept these constant values. Okay, they show up as strings, right? So we're going to change that to S, and if you don't do it, you're going to get some red. You're going to get, Java is not going to like you. It's not going to like it so much. So here we're going to do please pick a suit for your card. And now what we're going to do is we no longer have the card.suits.length, but we have, remember we used that array, we called it card suits dot.length. Okay. And we're going to do and here we're going to change this to card suits as well. Okay. And we're going to click on save. And now we're going to do, we're going to call this int suit. And I think I can leave it. I'm going to call this suit position, because that's what this is giving us, right? Position. Okay. Int suit position is input.nextInt. And remember, we're displaying it with a +1 to the user, and the array is 0 based. So I'm actually going to subtract 1 from here. Okay. And I'm going to hit save. And now I'm going to pick a suit for your card. We already did that. I'm actually going to do enter a value. I'm going to remove this 1 to 13, because that's presupposing I know how many different values are in a card. And we are going to add some, and we're going to see how easy it is once we do all of this legwork. So I'm going to say, please enter a value. And now instead of doing this, we're actually going to do is we're going to have a loop. We're going to do something similar to here. So you know what? Let me just go ahead and copy it. And I'm going to refactor that. And okay, so you notice now sometimes when you copy, the formatting is not good. Very first thing I do is I do source format. Okay. And now this is not going to be card suits. This is going to be card values. And again, this is not going to be card suits. This is going to be card values. So here, now we'll be able to see, instead of it being like the king is 13 or whatever, we're actually going to see ace, king, ace, jack, and queen, king. So now we're actually going to continue, but we're doing the same thing. We're adding 1. And so here I'm going to do value position as well. Is equal to input.nextInt, and the same thing, we're adding 1 for the user to make it easier to see. So we're going to subtract that, and and again, I'm assuming the user is entering valid data. Okay. Again, if this was something to hand in, you'd obviously want to make sure you could have a loop, right? And until as long as the user enters one of these values. Okay. So now what we're going to do is user guess is equal to, and this is going to be, we have to access the array. This is the values array. So this is card values and a value position. Value position. Where is it? That's control space, by the way. And I'm going to do the second one. This is the second parameter. So this is what is this doing? Just as a review, this is actually calling the new keyword operator actually invokes the constructor. Here's our constructor, and our constructor is expecting 2 parameters, and the first parameter is value, and the second parameter is suit. So here's where we're passing in the value, and now we want to pass in the suit. So here we're going to do the card suits dot, not dot, and suit position. Okay. Yeah, this video is going to be long. It is a lot. It is a lot. I cover this in a 3-hour class, and it is a lot actually. So let's go ahead and continue. So now, because suit is no longer a string, we can actually use the equal. So we get rid of the dependency on the strings dot equals, I should say. Let's go ahead and save. Ooh, no more red. And now what we're going to do is let me do something. And when you're doing a lot of refactoring like this, and this happened to me during class, sometimes NetBeans gets a little bit confused, and it's good every once in a while to do a clean and build. Okay, let's go ahead and do that. What this does is, if you remember from your early Java days, when you compile, it creates a class file which contains the bytecode. And sometimes NetBeans just leaves the old bytecode there. So you're looking at the source code, and it looks like it should work. Then you look at the you don't look at the bytecode, but the bytecode is not in sync with the source code. Okay, so NetBeans, at least it has that functionality to do it. So let's go ahead and run it. Let's go ahead and run it. And okay, so now we see that, oh, look at that. We have 2 of diamonds, 3 of hearts. We have ace, you know, kings and stuff. So that's kind of cool. And here it's displaying it's displaying the suits. I'm going to pick 2 for clubs, and let's do the ace. And see, now we also have the, you know, the cards. I'm going to do the ace. It says right guess. Okay, so let me try to do one that shouldn't work. And let's do the, let's see, hearts. 10 of hearts. Is 10 of hearts? Yeah, let's do the 10 of hearts. And 1 and 10. 10 is 10, right? Yeah. Okay, so no match. So we see that works. So you might be thinking, well, you know what, it was working before, but geez, that's a lot of work. We're like almost an hour into this video, but let me show you how the hard work pays off. Let me go, and so now card and card game are very loosely coupled. Okay, there's still some dependencies. Obviously, we're using it, right? We have the imports, but now let's see where the beauty of how our hard work pays off. I'm going to add a new suit. I'm going to add star. Why not? And I'm also going to add a new value. And that value, I'm going to call it emperor. Whoops. Emperor. So we can have an emperor of star. And I'm going to go ahead and save this. And if I hit run, okay, so here we see that we have both. Actually, we have the star, the 2 of star, and we have the emperor of clubs. Okay, so, and notice here as well, in our prompt, the star is already there, right? The star is there. Why is it there in the prompt? Because when we're prompting the user, and here's where we're prompting for the suit. Notice we're looping through the whole array, and we're displaying everything that's in the array. So we are getting all of the values, card values at the top, and we're getting all the possible suits. So we added it in the card class, and we see that it's available right away in our other class. So I'm going to go ahead and I'm going to pick star. And what was the 2 of star? And see, and notice as well the emperor showing up. So I'm going to do the 2 of star and right guess. So we see everything is working. And we can also see, again, so you see how easy it is to modify. Now I took out 2, and I'm going to hit run. And notice here I can only choose from the 3 that are there. So you see right now these two classes are extremely loosely coupled. If I want to do changes to my card deck, all I have to do is change card. There's no code change in card game whatsoever. So this is kind of a very, very nice example. And I'm just going to put this back, hearts, clubs, spades, and hearts, clubs, spades, and what was the other one? There we go, diamonds. I'm going to take away the star. And I'm going to take away the emperor as well. And I'm going to commit this as loosely coupled. Okay? Let's go ahead and do that. And I'm going to right click. And I'm going to commit. And I'm going to commit this as after refactoring. Refactoring using Enums. That's it for loosely. Okay, so let's go ahead and commit. Notice a capital here and a lowercase there. I like to be consistent. There we go. And we're going to be 2 ahead of the main. Sorry, my bad. One last thing, very, very last thing I want to show you. If you're still here, pat yourself on the one last thing I want to show you is how we can increase the cohesiveness by creating a class that will generate the card hand. So let's go ahead. So actually, you saw that I was using Visual Paradigm. So I'm going to open it up again. And I'm going to go to my team. Let's go, view. And we're going to go to our Diagram Navigator. We're going to go to our UML, our class diagram, card game, and yep, sometimes NetBeans likes to open things where it likes to open them. And I'm going to create a new class here, just like we did before. I'm going to create this class. This class is going to be called Card Hand Generator. Yep, Card Hand Generator. And hit enter. What I'm going to do is I'm actually going to create a static method. Come on. Come on. There we go. I'm going to create a static method. I'll show you how to do that. I'm going to create an operation that's called generate hand. Generate hand. And what we're going to pass in a parameter, num cards. How many cards do we want to generate? And that's going to be an int. And we're going to be returning an array of cards. And what I'm going to do as well is I'm going to right click. I'm going to make this static so we don't have to create an instance. And we're going to put the static is actually put in, it's in the scope, which is it's a bit funny, but the instance is obviously instance. The visual paradigm calls static classifiers. Let's go ahead and do that. And I think that's probably the UML way of doing it. And now what we're going to do is we're going to update the code and go to our Project Explorer. And again, if you're having a hard time finding it, it's right here. And we're going to see, here's that new card, that new class. And what I'm going to do is in the card game class, here's where we're creating them. So I'm actually going to use a random number. We're going to do this. I'm going to have to modify the method a little bit. I don't know if anybody noticed that, if anybody's still listening. But I'm going to go ahead and I'm going to reformat. I'm going to need to pass in a few things. I'm going to have to pass in the card values and the card suits. Okay, so I have to add a couple parameters. So here is going to be a value, array of values called card values. And also I can make this a little bit, or I can put it on more than one line of code. There we go. And I'm also going to do the suit, same with the suit and card suits. And I have to import both of those. So first we're going to import the suit, then we're going to import the value. And lastly, we're going to have to create an we're going to have to create an array. So let's go ahead and do that, because remember this method returns an array of cards. So let's go ahead and do that. So we're going to card, and we call it hand, is equal to new card. And how big? Well, we're passing in the number of cards. Okay, so let's go ahead and do that. Number cards. And also what we have to, there we go. So our method is almost complete. And right. Let's not worry too much about the Java docs. Okay, let's just, Java docs is important, but in this, yeah, it's just, we're already an hour over. So right now we have this, and notice it's not compiling because we're missing a return statement. Let's go ahead and return the hand. So what did we do? We just created just use the code that generates the card hand, put it in this method. Okay, so now we're actually going to, we still have this card hand here. We're going to remove this. And notice once we remove that, our code, and we save, our code won't compile anymore. So now we have to get the hand. So card hand is equal to, and then because we generated that, we created that as a And that's control space, by the way. But because we created this as a static method, we don't have to create an instance. And here we're going to pass in the 7 because we want 7, and the IDE was smart enough to do the card values and the card suit. Let's go ahead and save this, and we're just going to check to see if it's still running, and we're going to hit run. And we'll see, yep, ace of clubs. Let me go ahead and do the ace of clubs, and the ace. It works. And let's try one last one, something that fails. So the 10 of clubs isn't there. Okay, so that's it. Long video. I hope it helped you. I know you can pause, fast forward, but anyway, I hope you enjoyed it, and please comment, rate, subscribe, and thanks for watching. Bye-bye now.